In the second part of lesson 1.3, we're going to talk specifically about the equations of lines that are parallel and perpendicular to each other. So first off, parallel lines are defined as two non-vertical lines, and they are parallel if and only if their slopes are equal. So we're going to fill in the blank with slopes are equal and they have different y-intercepts. Okay, so parallel lines basically have the same slope. Perpendicular lines, I'm just going to draw, this is how I designate parallel lines. And perpendicular lines, I usually designate them like this. Parallel lines are two non-vertical lines, and they're perpendicular if the product of their slopes is -1, which means that their slopes are opposites and reciprocals. All right, so for example, if one line has a slope of 3/2, line 2, if it is perpendicular, will have the opposite. So if this is positive, this has to be negative, and then the reciprocal would be 2/3. So one slope is 3/2. The perpendicular slope is -2/3. So in example 8, it asks us to determine if these two lines are parallel. Okay, so if they are parallel, they will have the same slope. To determine if they have the same slope, we need to put these in slope-intercept form. So we need to solve for y. So here, if I subtract 2x, I'm going to have 3y equals -2x plus 6. Divide all parts by 3. So y is -2/3 times x plus 2. So here's the equation for line 1. And in line 1, the slope is -2/3. In this line, I'm going to subtract 4x, move it to the other side, so I have 6y equals -4x. And I can leave that plus 0 for the y-intercept if I want. If I divide by 6 on all parts, I get y is negative, if I reduce this, 2/3 times x plus 0. And in this equation, this slope is -2/3. So because these slopes are equal, they are parallel. Yes, they are parallel. Notice in the definitions it says they're non-vertical lines, they're parallel if their slopes are equal and they have different y-intercepts. These do have different y-intercepts, and that's necessary because if they had the same y-intercept and the same slope, these would be the same line. Okay, so if it's going to be parallel, it has to be through a different point on the y-axis. Example 9 asks us to find the equation of the line that contains the point 2, -3 and is parallel to the line 2x plus y equals 6. All right, so we're writing an equation of a line. I know I have a point, and this is going to be my x1 and y1 value. Oops, that didn't look good. So this is x1 and y1, and it's going to be parallel to this line, so it's going to have the same slope as this line. So I need to find out what that slope is. So same slope. So I'm going to subtract 2x, so I have y equals negative 2x plus 6. And the slope here is going to be negative 2. So this time I'm going to have this point and this slope, and I'm going to write the equation. So since I have a point on the line and the slope, I'm going to start off with y minus y1 equals the slope times x minus x1. Now I'm going to plug in those pieces that I know, my y1, my slope, and my x1. My y1 from here is negative 3, so this is y minus negative 3, so y plus 3 equals the slope, which is negative 2, times x minus 2. And I'm going to simplify this, and it doesn't tell me how I'm going to write the equation of line. What's my ending equation going to look like? Usually if it doesn't tell us, we put it in standard form. So to put it in standard form, I'm going to get x and y on the same side and the constant on the right side. So if I distribute, I have y plus 3 is negative 2x plus 4, as I'm distributing here. And I'm going to add, well, let's look at this. I want to get x and y on the same side. Notice x is negative here, so if I add it to this side, x would become positive. So I have positive 2x plus y equals, so I move that over, and I'm going to move this to the other side, and I'm going to subtract 3, and that would give me 1. So this is the equation of the line that's parallel to this line, but goes through this point. Okay, in standard form, remember x and y are on the same side. There's no fractions here or decimals, and the x term has to be positive. In example 10, it asks me to write an equation of a line that is perpendicular to another line. The original line has slope 3/2. The equation of a line that's perpendicular, remember that line is going to have a slope that's opposite and reciprocal to this. So this perpendicular line would have the slope of negative 2/3, and it's going to go through this point, negative 1, 1. So this is going to be my x1 and y1 value. Again, we'll start with point slope form. Y minus y1 is the slope times x minus x1. If I plug in the pieces, y minus 1 equals the new slope, the perpendicular slope is negative 2/3, times x minus x1, which is negative 1. So I'm going to have x minus negative 1, or x plus 1. All right, so I'm not going to leave it in point slope form. Let's distribute and see what happens here. I have y minus 1 equals negative 2/3 times x, and negative 2/3 times 1 is minus 2/3. All right, so if I'm going to put this in standard form or general form, however we want to call it. Different textbooks call it different names, either standard or general. To me, it's the same thing. But to do that, I need to get x and y on the same side. I can't have fractions, and x has to be positive. So the first thing I'm going to do is get rid of the fractions. And to do that, I'm going to multiply both sides by the common denominator of my fraction, which is 3. So I'm going to multiply both sides by 3. This gives me 3y minus 3 equals, now I need to distribute the 3 on this side, and I'm going to have 3 times negative 2/3. The 3's will cancel, so I have negative 2x, and 3 times negative 2/3, again the 3's will cancel, would be minus 2. To put it in standard form, I'm going to add the 2x to the other side. So I'm going to go up here. So I'm going to get 2x plus 3y, and I'm going to add the 3 to this side. And negative 2 plus 3 is 1. And this is the equation of the line in standard form that would be perpendicular to a line that has this slope. One more example, number 11 here. Find the equation of a line that contains this point, and it's perpendicular to this line, and we're going to graph the two lines. So first, let's start off with this line, and before we can graph it, or we could graph it without solving for y by using intercepts. If I do that, my x-intercept is going to be 6 because I'll plug in 0 for y. So I have x equals 6. 1, 2, 3, 4, 5, 6. And y would be 2 because 3 times 2 is 6. So my y-intercept is 2. So here's my first line. I also need to find the slope of this line, so I need to solve for y. So I'm going to subtract x. 3y equals negative x plus 6. Divide all parts by 3, and y would equal negative 1/3 times x plus 2. Now, if I go back to my line, my y-intercept, if x is 0, y is 2. So I start here. I'm going down 1 over 3, down 1 over 3. So this is, again, the line that we drew with the intercepts. So if this is in slope-intercept form, I know that this slope is negative 1/3. Now that's important because I need to find the line that's perpendicular to this. So my perpendicular slope is going to be the opposite, which would be positive, and the reciprocal, which would be 3. So my new slope for my new line is 3, or 3 over 1. And the point that it's going to go through is 1, negative 2. So remember, this is my x1 and y1 value. I'm using point slope form because that's the information I have. I have a point and I have a slope. I'm going to plug these values in. So I have y minus negative 2, so y plus 2 equals my slope, which is 3 times x minus 1. Now I'm going to simplify this, and because I'm going to graph the line, let's just put this in slope-intercept form, so solve for y. So I'll have y plus 2 equals 3x minus 3 by distributing. then I'm going to subtract 2 on both sides, and y would equal 3x minus 5. So if I graph this line now, my y-intercept is going to be negative 5. So I'm going to go to negative 5. 1, 2, 3, 4, 5. That's my y-intercept, or my starting point on the y-axis. And my slope is 3, or 3 over 1. So I'm going to go up 3 and to the right 1. So from this point, up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. So here's my new line. And if you look at those lines, they do appear to be perpendicular because they appear to be right angles where the two lines intersect. Okay, so that's just kind of a check on that. All right, so we are all done with section 3, 1.3.